Hello and welcome to another video in CHE 101. This is the second part of the integral calculus topic, U-Substitution. I am Monito Felias and you may contact me through this DLSU email. For the outline of our topic, we'll begin with the introduction again of U-Substitution and then the formula sheet. These first two parts are the same as the one in the first video, and then our list of questions and complete solutions will follow. And then finally, the list of answers for the problems that we've solved. Again, please try to solve the problems first if you can. We have 6 problems for this video. You may take a picture of the list of questions later on and just use the video as a way to check your answers. Reviewing U-substitution, this is the counterpart of the chain rule, and we can use this to solve composite functions. And then the general step, first we let u be a portion of the integrand f of x, and then we solve for du in terms of x and dx, and then we substitute u and du from the first two parts into the integrand so that we can solve for the value of the integral, where we'll be getting an answer in terms of u. And then the last step is to undo the substitution so that our final answer is in terms of x. This is the formula sheet once again, which we will be using for the rest of the problems. Please take a picture of them if you would like to solve on your own. And our set of problems again are here. In the first video, we've answered the first 6. So now we'll be answering 7 to 12. Okay, so beginning with the problem number 7, we will be taking the integral of 5 e raised to x over 2 times the square root of 1 plus 5 e raised to x dx. And then again, we'll be finding which part complicates this integral, and then we will be letting u be equal to that part, that portion of the given. And some of the candidates here would be whatever is inside of the denominator, so this entire thing in the denominator, but getting du would probably be complicated that way. So maybe you can try just whatever is inside of the radical. So what's inside of the square root, we let that be equal to u. So u equals 1 plus 5 e raised to x. And then solving for du would be equal to the derivative of this times dx. So 5 e raised to x dx. And then substituting u and du into the given, 5 e raised to x dx is equal to du. So the numerator would just be having du. And then 2 times the square root of this whole thing, 1 plus 5 e raised to x is equal to u. So over 2 square root of u. And just rewriting that, we'll have the integral of u raised to negative 1/2 over 2 du. And then this one, we can solve this through using power rule. This integral is equal to u raised to 1/2 over 1/2. And then, of course, we have 2 in the denominator. And then plus c, or the constant of integration. Simplifying this, we'll be having the square root of u plus c, because the denominator will be equal to 1/2 times 2. And then u raised to 1/2 is square root of u. On doing the substitution, our final answer would be the square root of 1 plus 5 e raised to x plus c. So this monstrosity is reduced to this, which looks very simple compared to the given. Okay, number 8, we are asked to take the integral of sine squared of ln x over x cosine ln x dx. And just by looking at the given, we can probably assume that we should be letting u be equal to ln x, because that part really makes this integral hard to look at. So let's try that. U is equal to ln u. And then based on our derivative rules, du should be equal to 1 over x dx. Substituting u and du, we'll be getting the integral of sine squared u times du is equal to 1 over x, this part, times dx, so times du, and then over cosine of u. And then since this part here still looks complicated, maybe we could split them into 2 parts where we would be applying the Pythagorean identities. So sine squared u is equal to 1 minus cosine squared of u. And then from there, we can see that we can be canceling cosine in the second term. So let's do just that. So splitting that into two terms, this is the integral of 1 over cosine u minus cosine squared u over cosine u times du. And then again, we can cancel one of the cosine so that we are left with cosine u in the second term. And the reciprocal of cosine u is equal to secant u. So we now have two terms, and let's just remember that the integral of secant x dx, this is one of our formulas, that's equal to the natural log of the quantity tangent x plus secant x plus c, of course. And then we can solve for the integrals of these two separately. The integral of cosine x dx is also sine x plus c, which means that the integral of this whole thing is equal to the natural log of tangent u plus secant u plus negative of sine u plus c. And then just undoing the substitution, our final answer would be the natural log of tangent ln x plus secant ln x minus sine ln x plus c. So it's a bit lengthy, and this will be our boxed final answer. Okay, our third problem for this video, number 9, is the integral of e raised to x plus 4 over e raised to x plus 8 dx. So in here, it's not very obvious which part should be u. So with our previous examples, the trend is, it's as if we should be trying the denominator to be equal to u. So let's try just that. So let u be equal to e raised to x plus 8. Du would then be equal to the derivative of this times dx. So that's e raised to x dx. And solving for dx, that would be du over e raised to x, but e raised to x plus 8 is equal to u, which means dx is equal to du over u minus 8. And then this given, we can try to split them into two terms so that we can more easily substitute u and du into the given. After splitting them, we can substitute u and du. So for the first term, we know that e raised to x plus 8 is equal to u, and e raised to x dx is equal to du. So the first term is just du over u. The second term is 4 over e raised to x plus 8. And we know that this e raised to x plus 8 is u. We also know that dx is equal to du over u minus 8. So substituting those, we'll be getting these two terms. And then let's try solving for their integrals. The first part, the first term, d over u, is easy to integrate. That's just the natural log of u. But the second term feels still complicated and probably hard to solve. We can try maybe completing the square and then trying trigonometric identities. But for this solution, I stop here and consider this problem. Our substitution is probably invalid, or it probably complicates the problem even more. So let's try another substitution. This is the problem with U-substitution. So if your first substitution makes the problem harder, then an alternative way is to try another substitution, and that will be what we'll be doing. So maybe we can try u is equal to e raised to x. So that will have x plus 4 over x plus 8. And if that's e raised to x, du would then be equal to e raised to x dx. Which means that du over u is equal to dx because u is equal to e raised to x, right? So du over u equals dx. And let's try to plug that into our given. So we'll have the integral of u plus 4 over u plus 8 times du over u, which is dx. And then we can multiply the factors inside in the denominator. So u plus 8 times u, that's equal to u squared plus 8u. And then here we have another substitution. So after U substitution, we'll be trying V substitution just so we can make the give. Let's try substituting V equals U squared plus 8U. And dV would be equal to 2U plus 8U du. 2U plus 8. I think it should have been plus 8 lang without du. Du should have been erased in there. So 2U plus 8 du. dV over 2 is then equal to U plus 4 du. So please take note of the correction. There should have been no U in here. Just 2U plus 8. And then substituting V and dV into our integral, we'll be getting dV over 2V is equal to 1/2 of ln V plus C. And then plugging back our U into the V and dV substitution, we'll be getting 1/2 of the natural log of U squared plus 8U. That's our V previously. And then plus C. See how we've reduced this whole thing into just this very simple integral using V substitution. So this is the power of substitution. And then again, plugging back in the e raised to x terms into our U substitution, we'll be getting 1/2 times the natural log of e raised to 2x plus 8 times e raised to 2x plus c. And then we can try factoring this out just so we'll have a cleaner answer. We'll have 1/2 times the natural log of e raised to x times e raised to x plus 8 plus c. And we know that by the laws of the logarithm, we can split these product into two logarithms. So we did just that, and ln e raised to x, this is just x. So our final answer would be 1/2 of x times 1/2 times x plus the natural log of e raised to x plus 8, and then plus c, of course. So this problem is a bit complicated, and you might have to do the same for some of your problems as you solve in the course in Cal Ing 2. So in here, you can see that we've tried different U's. And then for our solution, we even tried a second substitution. So after letting U substitution, we also had V substitution here before we arrived at an answer. So if ever you might try some more solutions, this should be leading you to the same answer because there's no single solution usually in complicated problems when it comes to integrals. So as long as you arrive to the same or an answer that is equivalent to the answer that we're getting, that's also fine. You may not be needing this exact same solution. Okay, so moving on to the next problem. This is number 10. Hopefully this is shorter, but we are asked to integrate cosine of pi over x squared dx. So from the given, maybe what complicates this is the pi over x, or maybe it's the denominator, but let's see. We can try u equals pi over x first, and then du would be equal to negative pi over x squared dx. Solving for dx over x squared, that's negative du over pi, that's equal to dx over x squared. So from there, we could probably see that we're almost done with the integration because dx over x squared is equal to negative du over pi. Substituting u and du, will be getting negative of cosine u, so cosine of u, times du over pi. So that's this part, negative du over pi. And solving this, we'll be getting negative of sine u over pi plus c. So just a matter of undoing the substitution, we'll be getting a final answer of negative sine of pi over x over pi plus c. So this is our final answer. Now, a common mistake that I usually see is that some would treat pi as a variable. Remember that pi is a constant, just like 1, 2, 3, or some other constant. So it can be easily factored out. Uh, it can be manipulated just like any other constant. So don't be intimidated when you see pi in a given. Next problem, this is number 11. We'll be integrating 1 over this polynomial, 1 over 2x squared minus 12x plus 26 dx. The first thing that I did here is to factor out 1/2 because we can see here that all of the coefficients are even. And it's hard to solve integrals when there is a coefficient in the very first term of a polynomial. So maybe you can remove that and factor that out such that we are left with the product 1/2 times the integral of 1 over x squared minus 6x plus 13. Now we can probably just try substituting u into the denominator, but we can also take it one more step by splitting the denominator into this. So 13, that's equal to 9 plus 4. And the reason we split that in this very specific way is so we can use this x squared minus 6x plus 9, and we have just completed the square. This is a square trinomial. The square of a binomial, I mean. So this is x minus 3 squared. This part is x minus 3 squared. 4 is also a square, that's 2 squared. And looking at this is actually one of our formulas. This follows one of our formulas in the formula sheet. Remember that the integral of du over u squared plus a squared is equal to 1 over a times the arctangent of u over a plus c. So if we try letting u be equal to x minus 3, and then our a here is just 2, we can apply this formula. We can just simply substitute this formula and we'll have an answer in terms of u. So let's do just that. U is equal to x minus 3. Du will then be equal to dx. And substituting u and du, we'll be getting this whole thing as 1/2 of 1 over u squared plus 2 squared du. And then taking the integral of that using the formula, the answer would be 1/2 of 1 over a, that's 1 over 2, times the arctangent of u over a, that's u over 2, plus c, of course, always plus c. And then simplifying this is just 1/4 times the arctangent of u over 2 plus c. And then undoing the substitution, our final answer is 1/4 of the arctangent of x minus 3 plus 2, x minus 3 over 2, I mean, plus c. So that's our final answer for this question. Okay, so for our final problem, the last question is the integral of x cubed times the square root of x squared plus 1 dx. So again, based on the trend that we have seen from the previous problems, maybe we can try substituting u into the portion that is inside of the radical. So let u be equal to x squared plus 1. And with that, we can get du be equal to 2x dx. And since du is 2x dx, we might want to have something like x dx on the given. So we can factor out x cubed later on, such that we have x dx, which is equal to du over 2. So factoring out x cubed, that's x times x squared. And then, of course, we have the square root of x squared plus 1 times dx. So since we have x squared plus 1 is equal to u, we can also say that x squared is equal to u minus 1. With that, we can substitute x squared, x dx, and x squared plus 1 as their u and du equivalents into the function. So u minus 1, that's x squared, times the square root of u, that's the square root of x squared plus 1, times du over 2, that's x dx. Okay, so with that, we can distribute the square root of u on u and minus 1. So that would be equal to 1/2. That's the factor multiplied to the u 1/2 times u raised to 3 over 2. This is u times square root of u. And then minus u raised to 1/2. This is square root of u du. And then this integral, we can solve this using the power rule. So that's equal to 1/2 times the integral of u raised to 3 over 2 is u raised to 5 over 2 over 5 over 2 minus the integral of u raised to 1/2 is u raised to 3 over 2 over 3 over 2 plus c. And then just simplifying this is equal to 1/2 times the quantity 2 over 5 times u raised to 5 halves minus 2 over 3 times u raised to 3 halves. And then, of course, plus c again. And then we can cancel the 1/2 and the factor of 2 in both of these terms, where we will be left with u raised to 5 halves over 5 minus u raised to 3 halves over 3 plus c. And then just undoing the substitution, our final answer would be x squared plus 1 raised to 5 halves over 5 plus x squared plus 1 raised to 3 halves over 3 plus c. And that's the answer to the last question of our set. Again, here are the answers for the 12 problems that we have solved from part 1, the first 6 questions, and part 2, the last 6 questions. That's all for this video. If you have any questions, you may contact Chen Academics through our email and Facebook page. Thank you so much for listening and watching CHE 101. See you in another video.